Hi, have you ever wondered these questions? How do I run Python code directly in R? And more importantly, how do I run it on a web server like R Shiny? How do I do that? If you have those types of questions, like how do I run it? I'm nervous about virtual environments. How do I navigate this process? If you have those questions, then this video is for you. So please stay tuned. I'm Saniya Khullar, and I'm going to show you exactly how we do this. Hi everyone, I am Saniya Khullar, and in this video, I'm going to talk to you about how to run your Python code in R, and in particular in R Shiny, in a web development framework using R, but how you can run your Python code in R Shiny, which is a little bit more complex. And I'll have videos about R Studio and running Python in R. But how do you run code that you've written in another language, like Python, directly in a web development framework in R? And this is something that I was struggling on, that I thought I should make a video that would be very helpful for you guys. So I hope that it will help you, because I found this really cool tool and online help. So I wanted to share with you guys how to go about running it on Python code. And there's a package that's called Reticulate, where you can run your Python code directly in R, but sort of how do you translate it to running it on a web server or another web app, which is what R Shiny does? How do you kind of go about doing that? So I'm going to try to explain that. But firstly, let me talk about what Reticulate is. So Reticulate is basically this package that you can install in R Studio. And it's basically, it provides, which is R is a statistical software and computing software. And it provides a comprehensive set of tools to work between Python and R. So it's when you're working in R, but you've written Python code, instead of like trying to reinvent the wheel. If you've written code in Python, or if you have other code that you're using that people wrote in Python, you can run them directly in R using Reticulate. So it calls Python from R. So within R itself, you're calling Python code, like R Markdown, Python scripts, Python modules, and you can interactively use Python within an R session. And you can translate between R and Python objects, like R and pandas data frames, or R matrices and NumPy arrays, and these two can tend to be the same. It's flexible binding. So there are different examples of how you'd go about doing this. And I know that installing Python and getting it to work can be a bit tricky, using virtual environments and whatnot. And they have examples, which I'll try to go through in other videos, about how you can import pandas in R, which is Python code. And this is basically a pandas is a data package in Python, which lets you work with data. And so it's in Python, you can work with these data frames using the pandas package. So, and it's a cute name, like panda bears. You can import these modules like OS operating system. You can work on them a lot, work on Python code directly within R. So, it's really important to be able to work between two languages. My brother loves Python. He doesn't really know R as much. So if he writes code, for instance, in Python, I could run it really easily and happily in R with just a few tweaks. I also know Python. I love Python too, but it's pretty cool how you can work between two languages. And I also mentioned that we'll be talking about Shiny as well. So R Shiny allows you to use R to build these really cool web applications. A powerful and elegant framework for building web applications using R. You don't need to know HTML, CSS, or JavaScript. Though if you know it, it will certainly make your life easier, and it's a nice and shiny app to put for your data. So it's almost like Tableau a bit, where you can have a bunch of data connected to an app and have like these drop downs, have data visualization techniques, do a lot of powerful things and build all these cool web applications. You can have all these applications like a career pathfinder, immune system modeling, NCAA swimming, statistics. So it's all about using R to your data and building a really cool web application. And I had also made an example for one of my courses that is called Amazing Connections. It's sort of using Amazon data. It was for a data visualization class I was taking, and you can sort of see like you can have these drop downs and you have these metrics and all these, you have my logo, my smiley logo. You have all these things here available. So you can see it just takes a while to load up, but you can see about like different product categories on Amazon, and when you click through it, what are the children and the categories, and what are the subcategories. So like you can select all these different categories, and this is connected to Excel worksheets and workbooks, and this is all using R, and I wrote code. This is using Plotly, another library in R, to visualize these results. And then this is using another visualization library here. You can see some metrics. You can adjust it as well, potentially. If you just want to see the top 2 jigsaw puzzles. So yeah, it's pretty interactive and cool. And this is all used by R Shiny. So what if I want to run Python code in R Shiny in this web application? How do I do that? How? So let's see how we would go about doing that. So I was hunting a lot. I was getting really, oh gosh, it was a hair-pulling experience to figure that out, because I can run Reticulate directly in R by itself. But when you're calling a web app, and Shiny is something I've been looking at tutorials. I haven't taken a formal class, but I've been looking at tutorials and troubleshooting and trying to build a web tool and multiple web tools by trial and error. So how do you go about doing that? Well, I want to share with you this site, github.com, K, Shiny Reticulate app. And I wanted to show you because I'm also a visual learner. I learn best through examples, and I thought that this would be really helpful. This is an end-to-end tutorial creating an R Shiny app that uses the Reticulate package with Python 3. So hopefully you don't have to reinvent the wheel. You don't have to refactor your code in Python into R to make it work. Though I do think that if you have an app and it uses an R Shiny app using Reticulate, it might take up some memory. So that's something that you might want to consider, especially if you're using a free version of an app. I've been so far using free versions. So what you need to pay attention to is you need to have this Reticulate package. And it gets complicated because you need to think about virtual environments if you're installing other packages as well, how you would go about doing that. So what I thought was really helpful is this. And so this is an app, and they have a demo here of this app as well, Shiny and Reticulate, and some of the code is using Python. And this is version 3.5. And this is a setup first time, you can clone this directory, and you can install virtual environment and NumPy as well. And these are the packages that are used. So Reticulate, again, allows you to work on Python code directly in R. And this is an example, but I want to show you guys sort of how it can work together when you download it as well. And there's a small little fix that I made as well. Otherwise, I was looking at this and I was like, oh gosh, I was struggling on this. It was kind of difficult. So what I did is you can just clone it directly, or you can just download the zip. So I downloaded the zip file here. So when you download the zip, for instance, you can show in folder. So when you show it in the folder, you can just have it like, you can just do extract all. And when you do extract all, you can just extract to the same folder here. And it will then open up here. this directly has whatever you need to use for your R Shiny app. You sometimes you can place this directly in one file. If you place these two in one file, the UI and the server, which I typically do, if you place them in one file, then this will just be called the app. It'll be called app.r. And then what I found was really helpful is the code that is in this .r profile. So I've been looking at a lot of other sites to get this. This is your server, and this is your UI, user interface. And then this file over here will just be, this file right here will just have this file right here, Python functions that you want to write, and you can call as many functions as you want. So that's what you typically need to run this. So now let's go and let's try to open up these files. So directly in R itself. Now I'm going to have this R over here, and I'm going to show you guys. I'm going to open up this file here, and let's use the UI, user interface, and then let's also call the server as well. And we can just click run app for now. So let's see how this works. And I also want to open up the .r profile, but please don't just please leave this be. So we're just working with the standard results that and the code that has come on GitHub. So you can call, and this is an example of a web tool. You can see your system settings, your build, your login, your user, your effective user as well. Which Python do you have enabled, which Python. This is all information when you run this app that you will get about your Python versions. So, and then you can see Reticulate package, which Python are you using. So this is my login info, my machine, my desktop. This text is being printed by a Python function, and you can use the NumPy font package within Python to add two numbers here. So I told you that we had this code that we're calling. So if we go here to Python functions, I'm going to open it in Notepad++. Okay. So you can see import NumPy as NP, definition, test string function, return string, test math function, take two arguments, take or parameters X and Y, and then you return the sum. Test NumPy function, you can also add them directly, using NP, which is NumPy. Import NumPy as NP, that's a nickname for the package. So this is the name of this Python functions.py, which is here. Now, what you can see in the code here is that it's, using the Python NumPy package to add two numbers. So yeah, so I'm going to show you, I made a few tweaks to this R Shiny app that I got from the GitHub site as well. And guys, if you want to get the GitHub site link, you can also directly come here, and you can use this Shiny-Reticulate app on Rani K's site, which is really, really helpful as well. So thank you for that really helpful tutorial. It really helped me out a lot. So again, when you come to the app here, what you're going to see is you're going to see a bunch of files and Python functions. Again, it has the Python functions that you want to write and run in R directly. And these are very simplistic examples. So reality, you can have your complicated functions that you need written in Python, and they can be in the same folder as your app. You can either have a server in UI, or you can directly have one app that's just the app.r. It really depends on your preferences. server and then the user interface. So we're just going to see what sort of happens behind the scenes here. So in UI, it's sort of calling, the same things that you're running in your our Shiny server. So you don't really need to make many changes. You need to install install.packages. So you need to call this install.packages. You can sort of see the spinners as well being generated here, which is great. And then you can see that we have this example app using R Shiny and Reticulate, which is what this app is saying here. We have our sidebar panel, which is this part here, inputs to pure R functions here, distribution types. And I'll have another video explaining a bit about Shiny. You have your main panel here, which is, so this is your sidebar, and this is your main panel here. And then you have your tabs, you have using R and Python functions, which is the tab panel title. You also have architecture information, which is the name of the next tab panel. We have 2 tab panels here, which is great. And we're going to kind of see what happens in the server aspect, because that's sort of where, I made a few little tweaks. That's sort of where you would call Reticulate the package. So you can call your libraries here if you want to. And again, these can totally be in one file as long as you have like app.r. So you can have, these are your Python packages that you want to install that you're running from your script here. So you look at your Python script and see which packages you are importing. And that's sort of what you'd want to install, like pip, numpy, pandas. Just to be safe, please install at least these packages. So you do need this over here. The other thing is, one of the things that I have kept here is ignore installed. So within my code itself, what I ended up using in my code for this is the following. So what I ended up using in my code is the following. So for my, my work, what I ended up doing is so I have one file. So this has my app.r has my UI and my server in it directly. So you can see like my UI aspects above, and I have Python dependencies. So these are the packages that I used. It was a lot of trial and error. You could, as you can see below, there are a lot of comments in and out. I'm still working on clearing it up. But you can have my virtual environment directory, which I got directly from here. So the code here, Python path, which is sys.get environment Python path here. Then I had these packages that I'm calling in my R code, in my Python code, and I had to create this. So one of the things I did to get mine to work was I said the default was ignore underscore installed equals true. But I changed this to a false, and then it helped me get my code working. So I recommend changing it to false. And then Reticulate use virtual environment required is equal to true. So you're forcing Python to use this virtual environment. And then here I call Reticulate source Python. And then this file is directly, this Python file is in the same folder as the code that I want to use for my work. So, so here, like for instance, let me show you. I have my app and Within my app, I have a few other files, but I'm making a web tool, and within that, I have the code that I need to use within it. So I have some of my tools here, and I'm kind of having my the code within it directly. So that's what I recommend. So what you really just need is you need to have a variable before your server outside of any functions with the packages that you need. You need to have a virtual environment. You need to copy this code, please. Have this virtual environment being created. And then what you need is you need to have just these lines of code. So these lines of code are exactly copied from that link over there, from the GitHub site. So you need this, and you need this part here. This part I set to false. So this part is really, this is up to you if you want to set it to false or not. I set it to false. Then the other thing is that this part over here is going to really depend on your code. So you really need to call your Python function from within that. It needs to be in the same folder. And this part is also copied from it, but it's kind of based on which packages you need. So I kept, pip and numpy, and then I added scipy, pandas, datetime, and fss spec. So that's what you need to get that to work. And then you need to call reticulate source Python. That part you also need, where you're actually calling your Python script. And then it's sort of important that whatever you're using within Python, whatever the name of the function is you're working with, it's really important that you work with it within the server directly. That's what I found from my experience. So I'm calling this code here, and then in this file, I have and then sort of within that file, I'm sort of calling something that is called, okay, you can see it's organizing output file. And within that, I'm sort of calling reticulate R2Pi. It's a sort of a function that I'm using, and it's a gene regulatory network related. So I'm calling this information, and this function I'm getting from my Python code directly, and I'm running it as a reactive object within our server directly. So what that code looks like is that function is actually coming from here. One second, I'm just loading that. So what you'll notice here is within that code that I was running, this is the subnetworks and Python code new.py. And then I'm actually just calling this Python code directly. This is the function. I'm defining it here as well. I'm still working on tweaking it, but this is the function here. So, and I'm calling it directly in R itself, in my app itself. So similarly, what you need is you need this part here. You need the virtual environment directory, this part here. And you need to call the functions directly within R. So again, this is what you guys can take from here, is you need this. So library. You need directly that, with your Python functions that you're using, you need to call it directly in here. You need this part where you reticulate source Python functions.py. Please don't install Reticulate. I think because you have Reticulate here, you do not need library Reticulate. I think that could mess you up. So in essence, what you just really need is the following. So please ignore that. I think you just can have this here, have this. And because you are calling, and this part you're changing based on which packages you need. So I would recommend just keeping these for now. Having this here, and you can do ignored installed equals false. So have these here. This itself will kind of alert our Shiny that you're using Reticulate package, which is good. And then the other thing that you need to do is you can call the function directly. So Reticulate source Python is sort of reading in that Python file, Python functions.py. And then what that's telling is basically, hey, please just run in these functions here. So we can just check this out again, these Python functions. So one of them is test numpy function, or we can see where these functions are exactly called. And I recommend calling them directly within, a Python, within an R server function. So what you can see here is you can do Python config, discover that. That's sort of telling you which Python you're using, like sort of telling you which Python we're using, version, where everything is located, which could be helpful in case this doesn't work. I really hope this works for you. So test numpy function, test x plus y equals z. That's what that function is returning. So that's what x plus y, using the numpy Python package to add two numbers, x plus y equals 3. That's what this is saying. X z equals test numpy function input x. This is the x value that we're given, and input y is the y value that we're given, that we have gotten from here. This x is this x value, and this y is this y value. And because it's input in the UI part, then to reference it, we call it input. To reference this will be called input x, and this y will be, this y value here will be called input y. That's how we reference those. So basically, that's how this goes. And in our server, what we can see here is that we're doing the test numpy function with these two arguments here. And this is exactly calling this function from Python. It's calling this function that is Python functions.py that we have read in. And it's going to use numpy to add together our x and our y. What you see here is that you can test that the numpy function can be used by having output xy. So this is your input x and your input y again here. And then so you're taking this x value and then this y value, and then you're saying x plus y is z. So that's just like a way that you're sort of running this app here, and it's taking your x value and your y value, and it's adding them together. X plus y equals z, which is 3 here. And again, guys, this is the function that we got using our test numpy function from here, where we're adding these two inputs. We can do, and then be having this output xy here, which is using render text. So this is xy, it's sort of like its ID. And we can take this xy here, and then we can put it in verbatim text output as xy, and then we can sort of use that output here and call it, and it will print it out as well here. And then the next thing for you guys to see is that we can also call the test string function here as well, which is also imported from our Python function. So our test string function is one of those Python functions that we were importing. And we can basically do this overall. We can test our system, which our Python environment, getting the environment. This is sort of giving all the metrics about the architecture information about, which Python version are you using. So this is what I'm using. For your virtual environment information is your desktop, your Windows, your build. So this is all helpful information. So what I want to really tell you guys is the following. So this is some helpful advice. So please go here to github.com, Vanike Shiny Reticulate app, and you can download the code from there. So the code that is really helpful that I was using is from Shiny Reticulate app over here. You can use this code that I got here, guys. Again, you can just download it, work with it. Then, please copy whatever folder you're using. Please copy this r.r profile. Please copy that code into that app folder that you're using directly there. And you can also, so copy this, just copy it and you can paste it as needed. If you need to edit it at all, you can also do file.edit and you can do .r profile if you ever want to view it, or you can just view it directly. If you can go to that site, or you can directly pause this and just please make sure you copy and note this down. Here, this is virtual environment name, example and name, virtual env name here. And then you'll notice that that's sort of what we are setting, system.get environment virtual env name. And that's what we're setting here. And then we're basically trying to initialize it if it's Shiny. It was really complicated when I was trying without using this GitHub site. So please, I just recommend sticking with this, and please let me know if there's any issue as well. Just please use this R profile. You can copy it directly from there, or just copy this and pause the screen to copy this down. Then the next thing is you can install that packages, Shiny CSS loaders, and then you can have this library where it's sort of being called. So please, again, make sure that you have your Python file and the functions that are needed directly in the same folder. You can have server and UI, or you can just have app.r, but please make sure it's in the same folder. Outside of the code, please have a vector defined for the Python packages that you need. Like, I definitely recommend still having pip, numpy, and pandas. You see, we call numpy here, but just have it anyways in case you add in additional packages. So here you can see that it's called in the Shiny server, but outside of all the code, you have your Python dependencies there that are used. And then please do not call the Reticulate package in our Shiny. Please do not do library Reticulate. That may cause issues. That's caused some issues for some people. Within the server itself, if you have the app directly, you will have a server part, but so within it, please call these functions. So you can call what I've written over here, this is coming from here. So you can call this virtual, all these functions. And I said ignore installed is equal to false. I set it to false, so it worked for me. Please do what works for you. So you can copy down these function commands here within the server. And this all should be here using the .r profile that you can directly copy from that site, or you can copy from this video, word for word, like the dictation. I used to do that when I was a little pipsqueak. It was nice. And then please make sure that you import your Python functions to R. So you have to do reticulate source Python. Since we are not calling library reticulate, we can just reference reticulate this way. That seemed to be working for some people as well, and that was recommended. And this required equals T is sort of forcing this version of Python, this virtual environment that we've created. It's forcing our Shiny to use that. So we have our Python functions.py. Instead of that, you can call it whatever Python name that you have with your functions. And then I recommend that you call the functions directly within our Shiny server. So once you call it here, then you can, you can see test string function and test numpy function. These are all functions that were written in this Python _functions.py, which again was directly in the same folder, and this .r profile is there too. So you really just need to copy this, make sure you have a python.py file here that has your functions in it that you need to run, and then you can call them directly in your server and respond and react to them just like the typical, you would typically do in R. So I really, really hope that this helped you guys. I'm Saniya Khullar, having my cup of tea. So if you have any questions at all, please let me know. I'll try to help. This is something I was struggling on, and I found a solution through this, and I really hope that it can be helpful to you guys too. So yeah, please subscribe to my channel for more updates, and please let me know how it's going. I really hope that this can help you. And again, this is just a really cool way to be able to run our Shiny. In our Shiny, you can run Python code using Reticulate, and figuring out the virtual server and all that can be a headache. But hopefully this will help you guys. And this is a visual example of what you've seen online or maybe on help sites. So I just hope that this helps you guys. So all the best, and I hope that you have an awesome day.